Today we are using a specific formula. We are going to identify and use, we call it SOR, because it looks almost like S-O-R. And the different pieces are S is the arc length. Now you know what arc length is from geometry. So this would be the arc length here. Like if you're thinking about, it's like the crust of a pizza. That's the arc length. Theta is your angle measure. And the key to this one is it must be in radians. In radians. And R is, hopefully that's fairly clear, the radius. Okay, so those are the different pieces. So we're going to be given two of those and you got to find the third. That's the basic idea. Hopefully it's not too heart-wrenching. So here we go. In a circle of radius, an angle of 3 radians. So let's just move this up here for me. So you have to think about the circle, or you have to think about SOR. You got a circle. An angle of 3 radians. So it's a pretty big circle. So we're just going to do that. So this is 3. It can be radians without the pi, so you got to let that go. The arc length here is 12. We want to know what the radius is, so we have to use S equals theta R and put the pieces in the right place. So S is our 12, theta is 3, it's in radians, we do make sure we check that, and R is our radius. Divide by 3, R is 4. Can I have a test right now, Miss Bears? And a circle, so here we are. Just different versions of it. So try this one, putting it into the right place. Okay, so for this one, you do this, you just have to be careful. You are dealing with fractions, so you have to divide by 2/3 or multiply by the reciprocal, and you wind up getting 15. Okay, for this one, just reading it over, we have a central angle that intercepts an arc with a length of 75 pi. Okay, so we want to find the central angle. The intercept is an arc of length 75 pi. So the arc is 75 pi. So remember it says find the central angle. So you know we're going to be finding the theta and the S. So this is what we're going to find, and we're going to be given the S and the R. The radius of 30, and we just have to figure it. And we want the answer in terms of pi, so we just don't put pi in our calculator. So 75 pi equals 30 times theta. We divide by 30, reduce, and all is well. And we get 5 pi over 2 with it reduced. Okay, again, these are very similar, all basically the same thing. Try this out. Okay, for this particular one, just had to multiply them together. They give you the radius and the theta, the angle. Multiply them together and you get 62.4. All right, this one is one that causes us a little bit of an issue, because this says the central angle is 135 degrees. We can't have that. We do have to convert that to radians first before we can do the problem. So take a second and convert 135 degrees to radians. Okay, because it did not tell me to round, I'm not going to, and I'm going to convert this to 3 pi over 4. Okay, and then we just do the math. So when we do this, intercepts an arc on the circle, so the arc is 24, and the angle is 3 pi over 4 now, so the arc is 24. 3 pi over 4, and the radius. So I have to divide by 3 pi over 4. I'm not going to put pi in the calculator. I'm going to leave it in there. Okay, when I do this, I get 32. Oops, sorry. I get 32 equals my radius. Now, where does the pi go? So you have to remember that this problem, it's a keep, change, flip. 24 times 4 over 3 pi is actually what happened. You keep this the same, change that to multiplication, and then this gets flipped. So the pi winds up on the bottom. Okay, try this one on your own. Please note this is 450 degrees, so take that into account when you're doing the problem. Okay, this one had to use a couple skills of fractions. When you divide by 5 pi over 2, remember it's keep, change it to multiplication, and this gets flipped. So the pi's actually cancel themselves out, and then doing the math there, I get 5 for my radius. Okay, Steve buys a large pizza that is divided into 8 equal slices. So we've got a pizza here, and it's 8 slices. Okay, they're never equal when I get my pizza, but whatever. She measures along the outer edge of the crust, so that's our arc length. Okay, that's the S. From one piece and finds it to be 5.5 inches. Okay, so then that's our arc length. So S equals theta R. We got 5.5 or 5.5 as my arc length. Now, it seems like there might not be enough information, but what you have to remember is this guy is a circle. Bam, it's a full circle. So with a circle, it's 360 degrees, or if you want to get technical, it's 2 pi. So if we're dividing it into 8 equal slices, I'm taking the full circle, which is 2 pi of all these angles. Excuse me, I should do the angle part. The angle, and I'm dividing it by 8 because it's 8 equal slices. So that's theta would be pi over 4. It's a deep question, but you could have done this with 360 degrees, divided 360 degrees by 8. You would have gotten 45, and then converted it, and you would have gotten pi over 4. I just find it was easier because if you remember that a circle is 2 pi radians, divide that by 8. It's up to you. Whatever. So they want us to find the diameter of the pizza to the nearest inch. So first of all, they're saying diameter, not radius, and nearest inch, so I'm going to be putting pi into my calculator. So divide by pi over 4. When I do this, I get 7.0028, whatever, is my radius. So to the nearest inch, I'm going to take that, multiply it by 2, and I get 14.0 whatever, and so that would be 14 inches. All right, have a good day. Soar.